Hi everyone, David Millington here. I'm the C++ Builder Project Manager here at Embarcadero. And I'm going to give a very short lightning talk on using unique pointer with standard containers. The reason for this talk is that when I talk about using smart pointers and encourage people to move from using raw pointers to smart pointers, one very common question comes up, which is how does unique pointer, which is of the two smart pointers in C++11, unique pointer and shared pointer, the one that is the one that should be most commonly used, how does unique pointer work with collections? And there are probably two reasons for asking this. The first is that you cannot copy. So there's a little code snippet on screen, unique pointer foo b equals a, where a is another unique pointer foo, and that will not compile, and that's by design. But the second question is probably a throwback to auto pointer, which is a very old smart pointer that used to exist in C++. It's now deprecated and strongly recommended that you don't use it. And that was dangerous to use in collections. And the reason it was dangerous to use was because its copy construction would actually change the object that it was copying from. So it had a single owner of a pointer, and when you copy constructed an auto pointer from another, it would take ownership of that pointer, but it would set the one that was supposedly copying from to null pointer. So the semantics of how the code was written was very different to what it was actually doing, and that led to a lot of buggy code. And that is why unique pointer can't be assigned as in the code snippet on screen and can't be copy constructed either. But that leads to a lot of questions, such as how do you use it? And then there are a couple of other related questions, such as should containers store objects or pointers to objects? And how do you move unique pointer between containers? And you can see there's a screenshot of a quick Google search that I did, unique pointer with containers. The top 5 results, the top 4 results all Stack Overflow questions, people asking variations of these kind of questions. And the 5th is an introduction to unique pointer and discusses the same topic. So it's something that a lot of people really want to find out about. So here are the answers. Should containers store objects or pointers to objects? And like any recommendation with C++, there are always lots of variations to this, and it strongly depends, but pointers usually. And one reason for that is that if you're moving objects around inside your container, if you're sorting or inserting or something like that, then you're going to have to move a lot of memory, and you move and allocate less memory if you're dealing with pointers to something than if you're dealing with the thing itself. So a vector of ints is probably fine, but if you have a vector of large objects that take a lot of memory, then you will find that working with the container itself and changing the container itself will probably be a lot more performant if you have pointers to those objects. Like anything, it depends on your use case and your actual code. Second question, does a unique pointer work with collections? Yes, it does. And how do you move a unique pointer between containers using std move and std arrays? And to answer all of these, let's go and actually have a look at some code. So I have some short example code here to show using unique pointer. So the first question is, should you use unique pointer? And the answer is yes, because otherwise you end up with something like this. Here's a vector of test pointer, and you have to remember to manually delete. And of course you have to only delete once, and you have to track ownership, and all those other things that smart pointers are supposed to handle. Test here is a very simple class. It prints out when it's being constructed, when it's being destructed, and it has a method, say hello, to actually do something with it. So the first thing is creating instances inside a container. In place back is a very useful method. It uses perfect forwarding. That means that you construct directly inside the container without a temporary on the way. Very useful method. Second, accessing the pointers. If you want to loop over a container of unique pointers, you would probably write a fairly normal looking range-based for loop like this for auto I colon and then the variable that you're iterating over. And that will fail to compile, and the reason is that you get the value of the unique pointer, and of course being a unique pointer you're not allowed to copy like that. Rather, you should get a reference to the unique pointer inside the container itself. So I'm going to run this code and show what happens. It prints out found whenever it sees something, and it's going to print out the pointer, and of course I've just added 3 of them. So 3 of them being constructed, you can see with the address here, just the last 2 digits are different, and has found those same 3. Well, that's a good thing. Quick digression here on using smart pointers. There's a common question as well when you have a smart pointer of some sort in a container. How should you use it when you're passing an element of that container to a method? Should you pass a reference to the smart pointer itself? Should you pass the pointer that's being held? Or should you pass a reference? So the worst, or rather the least likely to be correct, is to pass the unique pointer itself. And the reason for that is that the parameter types in the method implicitly show the intent of how the parameter can be used. So if you pass a unique pointer, then your code is effectively saying that you need to have the unique pointer itself, not the pointer that it's holding. The only reason to deal with a unique pointer is to change ownership, to take ownership away from that unique pointer, for example. And that is presumably and normally a fairly rare operation. So you would not normally pass the unique pointer element of the container around itself. More likely would be is if you're not sure if the unique pointer holds a pointer or null pointer. So you pass the pointer itself that the unique pointer is holding, like so, with a test pointer here. But of course the thing about a pointer is that you don't know if it's valid or not, and so you have to test for that. And that can be completely valid. It's quite okay to have code where you may or may not be null, but the best code is code where you know for certain about the state, and that is more common. So this is completely valid to pass around the pointer that the smart pointer is holding. But even better would be to use a reference, and use this, of course, when you know that an object actually exists. If you know that a pointer has a valid value, then you pass a reference to that object. You don't pass the pointer itself. And so of these 3, passing a reference by dereferencing the smart pointer is probably the best code pattern to use. And of course, as with all advice, this strongly depends upon your actual code and your patterns of usage and that kind of thing. But as a general guide, I think these are good rules of thumb. So moving right ahead, because it's lightning talk and we don't have much time. Actually, I'm just going to show you very quickly using this. So you have 3 different ways of using it and the 3 elements. So I should get 9 things printed out. And yes, we have hello from, and we have 3 sets of the 3 items in the collection. So moving right ahead to moving. How do you do that? If you want to move from the vector that we had, which was called vFrom, I have an empty vector here, which I call v2, and I want to move from vFrom to v2. You do that using std_move, and I have an inserter here that controls how that's done. And like many idioms, you want to erase afterwards, and so don't have time to get into showing that without the erase, but just going to have some code here that prints out whether it moves successfully or not, just to indicate that this compiles and works. It's going to print out the first and the second vectors. So from now is empty, and to now has those 3 items in it. So a few links. The first one here is a great article on using unique pointer with the standard containers, and that has an interesting performance test on the value of sorting pointers as well. And the second are 2 good Stack Overflow questions about using unique pointer with containers. So over to Q&A.